In this video, we're looking at blood alcohol content, which is simply a measure of the amount of alcohol in your blood. We measure this in grams of alcohol per 100 ml of blood. So if you have a blood alcohol content of 0.06, that means there is 0.06 grams or 60 milligrams of alcohol in every 100 ml of your blood. This can be influenced by the number of standard drinks consumed and the person's mass, gender, fitness, health, and liver function. So blood alcohol content can be estimated using a BAC formula. So for males, that is 10N minus 7.5 H over 6.8 M. And for females, that is 10N minus 7.5 H over 5.5 N. So you'll notice there's a difference in the denominator between males and females. And different variables in here represent the BAC is the blood alcohol content, N is the number of standard drinks consumed, H is the number of hours drinking, and M is the mass in kilograms. So this is only an estimation because this is only taking into account weight, number of standard drinks, and gender, whereas as we saw before, other things also play a factor in it, like your health and your liver function, and this doesn't take into account that. So this is just a way to estimate kind of just an average person's blood alcohol content. So here's how we do it. Lara weighs 70 kilograms and has had 6 standard drinks in the past 3 hours. Estimate her BAC. Answer correct to 3 decimal places. So we start off with the formula, which for females is 10N minus 7.5 H over 5.5 M. So we have to kind of define our variables first to substitute. So N equals 6 because that's the number of standard drinks. H equals 3 because that's how many hours she was drinking for. And M is 70 because she weighs 70 kilograms. So we just make sure we substitute those things in the right place. So we have 10 times 6 minus 7.5 times 3 over 5.5 times 70. So any good calculator you have understands the idea of order of operations, so you can type it in straight away using brackets whenever you would need to use brackets just in case. And that is our unrounded answer. But remember that we also need to round it to 3 decimal places. So I've got 0.097 and after that is a 4, which is not going to round it up. So it's just going to be 0.097, and it's good to state what you rounded to in brackets afterwards. So we round to 3 decimal places. And a summary statement is always good as well. So therefore, Lara's blood alcohol content is estimated to be 0.097. So remember, this is all estimates because we don't know anything else about Lara. We don't know her health or her liver function or anything, so this is just an estimate. So New South Wales has different blood alcohol limits for different drivers. So you need a blood alcohol content of 0 if you are on your L's or P's, 0.02 for drivers of heavy vehicles, vehicles with dangerous loads, and drivers of public vehicles, buses and taxis. And for everybody else, it's 0.05. So blood alcohol content is measured with a breathalyzer, which is faster, or by analysing a sample of blood, which is more accurate. The number of hours to wait before driving can be estimated from your BAC. So here's a little formula. You just need to weight BAC over 0.015 before you drive. So let's have a go at that one. So Lara has a blood alcohol content of 0.097. How long should she wait before driving? Answer to the nearest minute. So all it is BAC over 0.015. We've already found that her BAC was 0.097. We substitute that one in, type in the calculator, and you get a bit of a mess. This kind of gives us a decimal answer. But we need nearest minute because we're in time. So there's a special button you can press on your calculator that's going to convert it into hours, minutes, and seconds. So when you press that button, it's going to change it to this. So what each part means is when it's next to the circle, it's hours. So we've got 6 hours, 28 minutes, and 0 seconds. So it's already kind of rounded for us. We just drop those 0 seconds off, and that's 6 hours and 28 minutes. So therefore, Lara should wait 6 hours and 28 minutes. Tables can be used to estimate BAC without using the formula. So that skips a step for you. So the table below shows the estimated BAC after 1 hour from having 1 to 6 standard drinks for 8 different body weights in kilograms. So we can read this table pretty easily. Delilah weighs 85 kilograms, consumes 3 standard drinks in an hour, Use the table to estimate her BAC. Is it legal for her to drive her car now? Let's have a look. So we've got 85 kilograms and 3 standard drinks. So we're starting in that 85 column. We're reading down until we see 3 drinks. And where they meet is 0.039. So Delilah's BAC after 1 hour is 0.039. This is below the limit of 0.05, so she can legally drive. If you were asked this question, they would tell you if she was a bus driver or if she was on her L plates. So if it doesn't, you can assume that her limit's going to be 0.05. So you can find the waiting time using a table as well. So Georgia weighs 65 kilograms, has had 4 drinks in an hour. How long should she wait before driving? Answers to the nearest minute again. So we've got the table. She weighs 65 kilograms, has had 4 drinks in an hour. We need to find her BAC first. So we need to use the table again. We're going 65. We're going down until we hit 4 drinks. That lands us at 0.074. So we substitute that into our formula. We need to calculate that. It comes out as a decimal. So we are going to press that button again. And that again gives us exactly 4 hours and 56 minutes. So summary statement, therefore, Georgia should wait 4 hours and 56 minutes. You can draw a graph from the table also. So draw a column graph for BAC for a body weight of 65 kilograms. Make the number of drinks the horizontal axis and the BAC the vertical axis. So in this column graph, we are only interested in the blood alcohol content of people with a weight of 65 kilograms. So we're going to simplify that down. We're only worried about this one. So we'll make a little mini table over here. So after 1 drink, for someone that weighs 65 kilograms, their blood alcohol content is going to be 0.006 and so on. So it wants the number of drinks to be the horizontal axis. So they're what each column is going to be. So number of drinks. So 1 is going to be 1 column, 2 will be the next and so on. And then the vertical axis is all of these numbers. Okay, so we need to make sure that our vertical axis goes up past 0.119. So we need to make sure we're working with a reasonable scale. We've already decided number of drinks is along the bottom here, and that's what all of our columns are going to be. And then this is the trickiest part, is knowing what we're stepping up by. So if we went up by 1s, we would immediately be beyond where we wanted to be. So we need to go up by something smaller. So going up by 0.02 works here. And yes, these points kind of do lie between these values a lot of the time, but this is more about a reasonable position than it is about precision. So in this case, we've got 1, this one goes to 0.06, which we should know is just underneath halfway because that's close to 0.01. So it's a little under halfway. And then we just keep going. We're making sure that these are reasonable positions for them to be in, and you just make the columns as tall as they need to be. And that's all.